Hello everyone. I'm going to discuss to you about chapter 1 from the book of Stephen Chapman. Chapter 1 is Stephen Chapman, Electric Machinery Fundamentals, 5th edition. Gipost na nako ang PDF ani sa site. And then, uh, so i-assignment mo na ako sa inyo hani nga basahon ang chapter 1 and I'll discuss this today. Okay, Chapter 1, Introduction to Machinery Principles. Objectives. Okay, itong pretest nga akong gihatag sa inyo is just based on the objectives na naa sa Chapter 1. So, kung mabantayan ninyo, ikan lang sa objectives. Since kanina mga objectives, mo na yung ipang-discuss under this chapter, Introduction to Machinery Principles. So, to test your prior knowledge, since naggibasa naman ninyo ang chapter 1, to test your prior knowledge, naghatag ko og pre-test sa inyo ha. So, objectives, number 1, learn the basics of rotational mechanics. No, pinaka-basic ng mga principles. So, angular velocity, angular acceleration, torque, and Newton's law of rotation. So, velocity, acceleration, and Newton's law, na-discuss naman na sa inyo ang physics. So, I know that naamoy prior knowledge kita na. So, kanina mga terms or kanina mga principles, girelate ni siya diri sa machines. So, ang machines, dili lang velocity. So, ang tawag sila is angular velocity, angular acceleration. And then, kanang torque, similar na siya sa force. And Newton's law for rotation. So, i-discuss po ng Newton's law of rotation. So, i-relate sa mga connection ng mga principles diri as a subject nga inyong giinulan. Kaduha, learn how to produce a magnetic field. So, saan pag-produce sa magnetic field. Understand magnetic circuits. Understand the behavior of ferromagnetic materials. So, saan ang ferromagnetic materials? And then understand hysteresis in ferromagnetic materials. Understand Faraday's law. Understand how to produce an induced force on a wire. Understand how to produce an induced voltage across a wire. And then understand the operation of a simple linear machines. And lastly, be able to work with real, reactive, and apparent powers. Since prerequisite ang electrical circuits 2 or circuits 2 ani nga subject, so familiar na mo ani real, reactive, and apparent power. So, igo na lang i-relate kung saan pagkuha ng mga real, reactive, and apparent powers in machines, sa mga machines. Okay, that's the objectives of this chapter. Let's proceed. Electrical machines, transformers, and daily life. Okay, so gisamarin lang ako ni this is from chapter 1. So, electrical machine is a device that can convert either mechanical energy to electrical energy or electrical energy to mechanical energy. So, ang usa ka machine matawag siya og ang usa ka butang matawag siya og electrical machines kung mo-convert siya og energy to energy. So, from mechanical energy to electrical energy or electrical energy to mechanical energy. So, duha lang. Mechanical to electrical and vice versa. When such a device is used to convert mechanical energy to electrical energy, so, kung ang usa ka device or usa ka machine mo convert from mechanical energy to electrical energy, so ang tawag sa iya is generator. So, pag generator, matawag siyang generator kung magamit siya to convert mechanical energy to electrical energy. Kung electrical energy to mechanical energy, ang tawag sa iya motor. And then, ang transformer is an electrical device that is closely related to electrical machines. It converts AC electrical energy at one voltage level to AC electrical energy at another voltage level. It operates on the same principles as generators and motors. Okay, so mao na siya ang mga electrical machines nga i-discuss pag-discuss nako under this topic. So these three types of electric devices are ubiquitous in modern daily life. Okay. So daghan kaig mga appliances, mga butang sa mga high-tech na karon nga naay generator, motor, transformers. Okay, electric motors in the home run many appliances and even in the workplace. Motors provide the motive power for almost all tools or power tools. So, kanang ref, may motor. So, sa paman ng mga appliances sa inyong balay, na mga gagmay nga transformers. So, dili lang transformer nga naa sa poste, na mga transformer for electronics. And the generators are necessary to supply the power used by all these motors. So, mag-uban ang duha. Okay, why are electric motors and generators so common? Electric power is a clean and efficient energy sources that is easy to transmit over long distances and easy to control. An electric motor does not require constant ventilation and fuel the way that an internal combustion engine does. So the motor is very well suited for use in environments where the pollutants associated with combustion are not desirable. So instead, heat or mechanical energy can be converted to electrical form at a distant location. The energy can be transmitted over long distances to the place where it is to be used, and it can be used cleanly in any home, office, or factory. Transformers aid this process by reducing the energy loss between the point of electric power generation and the point of its use. Okay, so mo to siyang ang reason nga no, common kaayo ang electric motors and generators. So efficient, clean, no? So efficient, wala kaayo losses. So and efficient energy sources. So maka-supply gid siya, and then it is clean, meaning wala kaayo pollutants, no? Wala dili kay siya maka-contribute sa pollution. And then ang electric motor, so di na mag-require of ventilation. Kay ang iyahang internal combustion engine, iyan ang gagamiton to okay, combustion engine does, so the motor is well suited for, wala na. Electric motor does not require constant ventilation and fuel the way that an internal combustion engine does. Okay. So, you will understand further kung unsay ipasabutan na once we go along with the subject or our discussion. Okay, a note of units and notation. The design and study of electric machines and power systems are among the oldest areas of electrical engineering. So, mao na siya ang pinaka ginastudihan yun when it comes to electrical studies, electrical engineering, electrical engineering technology. So, ang inyong kurso is diri sa ASAT is the first 3 years ng electrical engineering. At ang tawag diri ay electrical engineering technology since na ay mga trainings nga naka-integrate sa inyong kurso. But mo ni nag-study mo na ay subject ninyong electrical machines 1 because mo gyud ni ang isa sa mga oldest areas nga ginastudihan when you study electrical engineering. And this is very important. Okay. Volts, amperes, ohms, watts, and similar units, which are part of the metric system of units, have long been used to describe electrical quantities in machines. Okay, so na may English system, no, yung nga unit, system of unit, and then na ay system international or SI system or letawag to metric units. Okay, so normally diri as the Philippines or bisag sa ubang countries gagamit jud og SI units. So unsa na yung mga SI units? So mo na siya mga volts, amperes, ohms, watts, kilograms, meters, centimeters, mo na yung SI units. Okay, ang nagpili na ang nag-standardize taan ang module na siyang gamiton as kanang para magkasinabot gyud ang tanan when it comes to units. So na yung tawag nga Institute of Electrical Electronics Engineers. So sila ang nag-standardize taan ang kanang ang mga notation ng mga units ang gamiton. So to solving problems, of course, since SI man ang standard ng mga system of units nga gamiton, so kung ang given SI, so SI gid ang gamiton. But when a problem is using English system, okay lagi hapon as long as English system of units ang inyong gamiton. Though SI units have been adopted throughout most of the world, engineering students and working engineers must be familiar with both sets of units since they will encounter both throughout their professional lives. Okay, so before pa na-standardized nga SI units ang gamiton, ang English system ang ginagamit gyud sa urban countries. Mo nang mga foot, mga inch, mga yard, ug uban pa nga mga SI English system of units. So dili gid malikayan nga na mga problem, word problem nga ang given naka English system of units. So that is still okay, but kung sa standard yun, so SI units ang gamiton. Next, vectors, electrical phasors, and other complex values are not shown in boldface. Okay, so kung mag-represent, excuse ito nga ba na, no? Ginukdukay ang silingan. Okay, vectors, electrical phasors, and other complex values. Kanina mga principles or terms na encounter na ninyo ni sa physics and electrical circuits ni subject. Okay, so vectors, electrical phasors, and other complex values are shown in boldface. So morning letter F, bold. So naka-darken siya nga. Naka-darken siya nga F. So muna ang way to represent vectors, electrical phasors, and other complex values. Okay, when we say scalars are shown in italic phase. So medyo nakaslant. Yung big letter R, scalars. Magnetic quantities such as magnetomotive force is represented by special fonts. Okay, let's go to rotational motion, Newton's law, and power relationships. So sa mga relationships nila. Okay, shaft of the machine, it is an axis where almost all electric machines rotates. So uban sa inyo naka-open naman siguro o motors or generators. So familiar naman sa shaft of the machine. So mo na siya ang axis or kanang nasa tunga sa motor where electric machine rotates. Okay. A three-dimensional vector is required to completely describe the rotation of an object in space. Okay, so palihog ko, reviewhan ninyo ang vectors ikan sa physics hangtod dito sa electric circuits din yung mga subject aron makarelate mo sa three-dimensional vector. Even sa math na may topic aning vector sa calculus, differential integration nata. So, please review. Kay sa electrical machines 1 nga subject, application na lang na siya. So, ang pag-manipulate ng mga equations, dito na discuss sa math, sa physics, sa electric circuits subjects. Okay, machines normally turn on a fixed shaft, so the rotation is restricted to one angular dimension. Relative to a given end of machine's shaft, the direction of the rotation can be described as clockwise or counterclockwise. Okay, so normally, machines, nagyo na siya tuyukan, fixed nga shaft. So the rotation is restricted to one angular system. So dili magbalhin-balhin, dili magbago ang iyahang rotation. Isa ra gyud na siya ka angular dimension. And then duha ra gyud po na iyang direksyon, nga tawag og iyang rotation rather clockwise or counterclockwise. Counterclockwise angle of rotation mo na siya ang gina-assume always nga assume to be positive. Always remember that counterclockwise is assumed to be positive. Clockwise angle of rotation assumed to be negative. Okay, so isa ni sa mga question dito sa pretest. What is angular? Question ba na ko na what is angular position? Okay, angular position or ang symbol niya is theta. Kani, di mo na ma-highlight. Kani na gi-point sa arrow. Theta, spelling T-H-E-T-A. Dili theta nga ante ha. Theta. So, angular position of an object is the angle of which it is oriented, measured from some arbitrary reference point. It is usually measured in radians or degrees. It corresponds to the linear concept. It corresponds to the linear concept of distance along a line. Okay, so kung i-question ako ni sa pretest, mao ni ang answer ato. Okay. Ang katong question is intended to assess your prior knowledge sa chapter 1. So, makuha ninyo ni sa chapter 1. Nani sa chapter 1 tanan. Kanya kong gina-discuss karon. So, angular position, so theta of an object is the angle at which it is oriented. No, kung asa siya nag-start, kung sa orientation niya, measured from some arbitrary reference point. It is usually measured in radians or degrees. So, ang iyang unit, radians or degrees. It corresponds to the linear concept of distance along a line. Okay, angular velocity. Okay, omega. Omega ba ni siya? Okay, so mo niya ang symbol niya, no? Murag pinakatay nga W. Angular velocity or speed. No, kung sa physics pa, speed or velocity. Pag speed, katong walay direksyon. Ang speed, nag-state lang kung unsay kakusugon. Pag bitag velocity, so na siya direksyon. No, angular velocity. So, direksyon niya. So, kay machines man and then gatuyok man siya. So, ang iyang velocity is measured sa iyang pagtuyok. Kung ngayon taog katong sa physics ng mga velocity, no, sasakyanan for example, sa iyang velocity, so i-measure lang ang speed niya, velocity niya from starting point to finish point. So straight line. But when it comes to machine, gatuyok man na siya. So angular velocity unsa kakusugon ang iyang tuyok, no? Unsa kakusugon ang iyang tuyok, mo na siya tawag nga angular velocity. In English pa, kung dali sa book atong basahon, is the rate of change in angular position with respect to time. No? Rate of change. So, same ra ang iyahang definition sa velocity nga gi-define sa physics. Ang sa physics, it is the rate of change in position. Diri sa angular velocity, is the rate of change in angular position with respect to time. So, sa physics, the rate of change in position lang to siya with respect to time. Kani, angular position. It is defined as the rate of change of the angular displacement theta with respect to time. So, angular displacement or angular position. So, mo niya equation. So, pagbasa na to ani, angular velocity. So, remember that sa kani nga subject, kani nga symbol ang tawag ani angular velocity equal to derivative of angular displacement. Para mo pagbasa ha. Angular velocity is equal to the derivative of angular displacement with respect to time. So, mo na saktong pagbasa aning equation. Angular velocity is equal to derivative of angular displacement with respect to time. If the units of angular position are radians, then angular velocity is measured in radians per second. Okay, so sa angular position, i-discuss mo na ito ngayon na balik na dali. Sa angular position, pwede siya in radians, pwede po naka-degrees. Okay, so kung naka-radians siya, pag-apply diri sa angular velocity, kung naka-radians siya, of course, ang angular velocity should be radians per second. Pero kung naka-degrees ang iyang unit, of course, ang iyang unit, aning angular velocity would be degrees per second. Okay. Frequently, the speed is given in revolutions per second or revolutions per minute. Okay. So, nailahi-lahi ng mga symbol. So, angular velocity na ay subscript nga m. Pag angular velocity with na subscript nga m, so ang tawagan na angular velocity expressed in radians per second. So kung naay m nga subscript, pasabutan na ayang unit radians per second. Pag f with subscript m, angular velocity expressed in revolutions per second. And then n with the subscript of m, angular velocity gihapon siya expressed in revolutions per minute. And then m. So letter m, this letter indicates a mechanical quantity. Okay, so angular velocity with subscript in m angular velocity with the subscript of m is expressed in radians per second. So, remember this ng mga relationships. Okay, so kung relate na siya, ang angular velocity expressed in revolutions per minute is just equal to 60 times angular velocity nga expressed in revolutions per second. And then, angular velocity in revolutions per second is just equal to angular velocity expressed in radians per second divided by 2 pi. Okay, so muna siya. So, i-memorize na siya ng mga symbol. Anyway, online pa man ta. Pwede na naman mo tanaw ani. Pwede na tanaw sa book kung makalimot mo. But when it comes to face-to-face na and then na exam na actual, of course, hindi nyo na i-memorize. Wala open notes. And then, angular acceleration. So, appeal niya siya sa question sa pretest. So, ang angular acceleration, ang symbol niya is alpha. Is the rate of change in angular velocity with respect to time. So, same nagigapon sa physics. No, angular position, next, angular velocity, and then angular acceleration. So physics pa, position, velocity, and then acceleration. Mo gina siya ang tulo nga gina-studyhan sa physics. No? Sa sugod pa lang. But when it comes to electrical machines, i-relate ni siya ng mga terms and principles. So, machines man siya, dili straight ang iyahang movement, but rotational mo ng angular position, angular velocity, and then angular acceleration. Okay, what is angular acceleration? Is the rate of change in angular velocity with respect to time. Kung mo ni answer sa inyong pre-test, actually, pwede na ganyan siya isa ka-sentence ra. No? Is the rate of change in angular velocity with respect to time. It is assumed positive. So, kung napamisumpay nga kani, so tama yapon. It is assumed positive if the angular velocity is increasing in an algebraic sense. It is defined by, okay, so muna equation for angular acceleration. Angular acceleration is just equal to the derivative of angular velocity with respect to time. Okay, so positive ang angular acceleration kung ang iyang velocity nagkataas, nagka-increase over time. Negative ang iyang acceleration, yung quantity sa acceleration, kung ang iyang velocity nagka-decrease as time goes by. So, muna ang idea sa acceleration. If the unit of angular velocity in radians per second, so, kung unit daw sa angular velocity is radians per second, then angular acceleration is measured in radians per second squared. Okay, same nagyagyapon sa physics. Pag-position, no? Pag-position. Kung sa physics ha, ang position naka-meters. Meters or kilometers. Pag-velocity, naka-meter per second or kilometer per second. Or kilometer per hour. Pag-acceleration, sa physics gihapon, meter per second squared or kilometer per second squared. So, diri apod sa angular acceleration or diri sa machines, sa kaninga subject, ang angular position niya, ang unit, radians or degrees. But ato na lang uniform radians. Okay, sa angular position, naka-radians. Angular velocity, naka-radians per second. Angular acceleration, naka-radians per second squared. Okay, so muna siya ang kalahian sa ilang mga units, ang kalahian sa ilang application, and then formulas. Okay, dito sa torque. What is torque? Okay, so mao ni siya ang symbol sa torque. Mao siya og big letter T nga nakatay. Okay, so memorize that symbol. Torque can be loosely be called the twisting force of an object. Okay, sa physics, naputi nga tawag na force, no? Ang force applied, when a force is applied, na-adjay movement. Like, kung ituklod nimo ang baso da sa lamisa, of course, mamove yun ang baso. And then, kung ang sakyanan po ituklod, mamove yun po ang sakyanan. So, kaning torque, force gihapon ni siya. No, it is similar to force, pero ang iyahang movement is rotational. No? Pag rotational gani ang movement, ang force exerted, ang tawag ana is torque. Okay, torque can be loosely be called the twisting force. So, it is a kind of force nga ina-twist niya ang object. So, siya ang reason nga nung mutuyok ang machine. Naay mutuyok. So, naay torque. So, torque can be loosely be called twisting force of an object, on an object. When an object is rotating, its angular velocity is constant unless a torque is present in it. The greater the torque on the object, the more rapidly the angular velocity of the object changes. Kaya kung the more nga magkakusog ang twisting force, or the more nga magkataas magkataas ang amount of torque that is applied, of course, ang velocity niya magkataas pod. Kung magkataas pod ang velocity, magkataas pod ang angular acceleration. Okay, so the more rapidly the angular velocity of the object changes, kung mas greater ang torque applied on the object. Okay, the torque or twisting action depends on, okay, so mao ni siya ang no? Ang dili nagdepende ang torque or ang twisting action. Number 1, the magnitude of the applied force. So, magdepende ang twisting action, magdepende ang iyang pagtuyok kung unsa pud ang amount sa torque or sa applied force. Number 2, the distance between the axis of rotation and the line of action of the force. Okay, kung ituyok nimo ang pinaka-simple nga example, abot lang kung makarelate mo, kanang seesaw, no? Seesaw. Sa seesaw na amangyoy duha ka lingkuran ana sa tumoy, si katumoy. Kung same ang timbang sa duha ka tawo maglingkod sa seesaw, of course, same ang ilahang movement, no? Pero kung mas dako gani or mas bugat ganing ibutang sa pika side and then ang isa sa isa ka side gaan, ang direction ana dito ra gid paingon sa kung asa tong mas bugat, no? Kung himo na to siyang circle, lang ko nakasabot mo sa akong example, no? Kung i-circle nato na siya ang seesaw, ang iyahang rotation would be directed, no, towards sa katong mas bugat, no? Kay ang force man, katong force, ang force exerted on that side is greater atong gi-exert sa pikas side since gaan ang sa pikas side and then bugat ang sa pikas. So, pero sa ikaduha, may the distance between the axis of rotation and the line of action of the force. Pero bisag lahi sila og timbang, pero ang katong bugat og timbang mo paduol sa axis of rotation or kanang ginatawag nato nga center, and then mag-equal ang ilahang amount or mag-equal ang ilang timbang, or let's just say para ma-relate nato sa topic, mag-equal ang force. So wala movement nga mahitabo since naka-balance. Pero kung paano na to ang isa, ka tao sa pika side, and then kato na lang bugat ang naa, that is nga duol siya sa line of action or sa axis of rotation. Duol siya sa axis of rotation, mas lower, no, mas dito padulong ang iyang movement or iyang twisting action, and then mas lower ang pag-move, no, mas lower ang twisting force. Unlike kung dito siya sa tumoy malingkod, same ra na sa kanang magamit og bender, no, kaya na lang ang example, no, kung magamit og pipe bender, kagamit naman yun mo pipe bender kaya mo naman mo EIM in situ training. Kung dito ka sa duol sa ulo mo hawid, of course maglisod jud ka og tuyok sa bender, maglisod ka og bend. Pero kung imuhang kamot ibutang nimo sa tumoy sa handle sa bender, dali na siya tuyokon. So mo na siya mas nice nga example sa torque, sa twisting force. So kanang force nga inyong gi-apply anang handle sa bender, mo na siya ginatawag nga twisting force. So the greater the force nga inyong i-exert, the higher po the angular velocity. Kading example. Okay, next. The torque of an object is defined as the product of the force applied to the object and the smallest distance between the line of action of the force and the object's axis of rotation. Okay, so muna akong discuss ganina sa example. If R is a vector pointing from the axis of rotation to the point of application of the force, and if F, sama ni siya nga F, is the applied force, so kanina F, applied force, then the torque can be described as, so torque equal to force applied times the perpendicular distance. So kung unsa kalayo ang force dito sa point of application. Sabtan na niya sa example. So mo ni siya ang equation. Torque equal to force applied times vector pointing from the axis of rotation sine theta. So kung sa ito angle. So where theta is the angle between vector and the force. Okay, the unit of torque are newtons meter. Newton meters, not na S. The unit of torque are Newton meters in SI units and pound feet in English system. So, sama sa akong yun ganina, kung ang given sa problem, naka-English system, so English system inyong gamiton. Pero pwede na po nga i-convert ninyo na tanan units into SI units. Okay ra gyapon. Newton's law for objects moving along a straight line describes the relationship between the force applied to an object and its resulting acceleration. So, ako naman yung i-discuss ganyan na, relate na ako ganina, force, torque. Okay, so mo ni siya ang sa Newton's law. Okay, so I will continue the discussion later. Okay, nagsakit na akong tilaw. So you review the things I discussed para ma-refresh ang inyong memory sa physics o sa electrical circuits, even sa math ninyo. Okay, that's all. So if na may question, just raise it in the group chat.